I'm really delighted to welcome you to the fifth event of the Royal Academy of Engineering Café series, Connecting Awardees, Fostering Engagement. I'm Professor Raffaella Ocone. I'm Professor of Chemical Engineering at Hertford University in Edinburgh, and I'm a Fellow of the Royal Academy, and I have served on a number of committees of the Academy. Currently, I'm the Deputy Chair of the Chairs in Emerging Technology Committee, and I will be the chair for this morning's session. This Academy Café series is a single part of an ongoing support for current and previous awardees, and we hope that we can build this activity even further. The series will cover a broad range of topics, and the discussion will be feed into the Academy's policy work. As I said, this is the fifth series, and today we are really delighted to welcome you for the discussion on improving safety at the end of engineered life. We will begin with a brief introduction and a conversation between me and our guest speaker, followed by the opportunity for you all to pose questions. Please do not refrain to pose questions at any time really during the conversation. You can, of course, use the box that is available. Before anything else, I would like just to draw your attention to the usual Zoom meeting etiquette. We should all be very much acquainted with this now, but nevertheless, I would like to remind you to switch your mobile phone and laptop notification to do not disturb, and please make sure that you are in a very quiet space. Also, please note that we are recording this event, and this may be published on the Royal Academy of Engineering website. During the Q&A session, we will invite you to switch all the cameras on. It will be nice to have the full audience together with us. And throughout the event, please submit your questions simply by clicking on the chat feature. So you will have you will see in your screen that there is the chat feature. There will be a box, and you can post your questions. Another possibility for you will be just to ask verbally your questions. This is also possible. If you like to do so, go to the participant list and just raise your hand, and then this will give you the opportunity to pose your questions directly to the speaker. And again, we would like to ask you, if possible, to have your camera on for the questions. Now, of course, we will cover as many questions as possible, but this depends very much on the time. Now, going back to the event of today, just a brief introduction from me. Few engineered products and structures last indefinitely. And this is just because the design or because technical and functionally and stylistically sometimes become obsolete. So these products and structure can be said to have completed the use phase, and therefore they have reached the end of life, engineered life. There is a very big issue about sometimes, unfortunately, this is mismanaged, and the end of life products and structures can be really hazardous, and it can be extremely harmful to people and the environment, of course. The associated safety challenges are often displaced to parts of the world least able to manage them. And this is an additional issue that we should consider as engineers. By trying to think about this critical issue from the beginning of the project, and of course throughout the design process, we hope that we are able to embed good practice and reduce the number of incidents, accidents, casualties that can occur and unfortunately still occur as a result of safety issues. And of course, I mean, we would like also to address the environmental impact, and poor management of waste, for instance, can be very, very harmful for the environment and for people, of course. I'm extremely delighted to discuss about these very relevant issues in our daily life with today's speaker, Professor Susan Gourvenec Gourvenec, sorry, my camera is doing strange things. Susan is an advisory member of the Engineering X Safer End of Engineered Life Program Board and team leader for safer decommissioning of offshore structures and ships. Susan holds a Royal Academy of Engineering chair in emerging technologies in intelligent and resilient ocean engineering. Susan is a professor of offshore geotechnical engineering at Southampton University, and she is a civil engineer by background, got her PhD at Southampton, and then she left for almost 20 years, I suppose. She went to Cambridge University, and then she went to Perth, but not Perth next to me, in Scotland, but Perth, Western Australia, where she started to work on offshore engineering. That is when she started the excellent work that she's doing in offshore engineering. Her current work at the University of Southampton drives activities to create a step change in ocean engineering design. And this work supports responsible, sustainable, and economic ocean development. And last but not least, Susan is really an advocate of diversity and inclusion. She chaired the inaugural Athena Swan Committee in Engineering at the Faculty of UWA in Perth, and she has been very active in this area also at Southampton. Without any further ado, welcome, Susan, and I think that we really would like to start the discussion now, and it's up to me to ask you just a starting question, really. We have spoken about the safer end of engineering life, and how does this feature in your research? How does this field, this area, influences your research?
Okay, well, thank you, Raffaella, for a lovely introduction, and very nice to be here today having conversation with you and everybody. So my chair in emerging technologies really looks at addressing technology gaps across the whole engineered life cycle of ocean structures. And so that can be from characterization of the seabed and understanding the evolving engineering properties of seabeds as infrastructure that is built on or in those seabeds impacts and applies loads to the seabed. The engineering properties of the seabed change. That in turn affects how that will impact on the structure during the next loading, which affects the change in the seabed materials. And of course, this process goes on throughout the engineered life of the structure and has clear implications at the end of engineered life for example, being able to predict the crane and vessel capacity that you might need in order to overcome the resistance to remove seabed infrastructure from the seabed, or equally to assess the stability of infrastructure that's going to remain on the seabed beyond its initial design life. Other aspects of the work look at smart mooring and anchoring systems and foundations. So this makes them smaller, optimized. So the end of life burden is of smaller magnitude. Aspects include looking at monitoring and smart ways of sensing structures. So we have a much better understanding of the integrity of an asset when it comes to the end of engineered life. Sometimes these structures might have a 50-year design life, and so understanding how they have performed relative to the expectations at design is very important. And I suppose holistically, part of the research is about challenging those existing design paradigms and philosophies so that end of engineered life is really embedded at the start of the process in the design phase. So design for decommissioning and how future ocean development could look where decommissioning is really embedded in the design stage, and that therefore reducing the burden of decommissioning at the end of engineered life.
Thank you, Susan. I think that there are two issues there that I would like really to explore a little bit with you. You rightly said that this has to be very much embedded in what we do from the very beginning. And of course, I mean, this is probably part of the design, the way we start to design our engineering products and processes. But there is also another aspect there. I mean, you clearly in your work are attacking quite a number of steps towards the final product. But can you see also other areas where this kind of approach would be necessary? In other words, what are, you think, the sectors or the industries that should do the same sort, should have the same sort of approach? And what are the opportunities for engineers and the opportunity also for research in this area?
So I think that's a great question, and I think, well, certainly across ocean engineering, there's a clear need for considering end of engineered life and how to embed that at the design stage. The quantity of infrastructure being installed in our oceans is increasing exponentially, and so that creates this huge asset base. But equally, there are many other sectors that are growing very rapidly at the moment, and whether that's medical waste and PPE, which has seen a huge increase just in the last year due to COVID. E-waste has been something that has been established, but increasing again very rapidly, and a huge burden on the end of engineered life landscape and how that is disposed of. But everything, whether it's offshore structures and ships or other big transportation infrastructure, planes and cars, or construction waste, even our domestic waste and that we put in our bins every day, is a huge volume of stuff that needs to be dealt with at the end of engineered life. And as you said in your introduction, often that is displaced to areas of the world that are least able to manage with that burden.
Yeah, and I'm a chemical engineer, and of course, I mean, there is in our chemical industries many areas that I think need urgent intervention in the way that you are saying, and of course, last but not least, the nuclear area, and where amazingly enough, some of my students get work in decommissioning. And of course, there are so many issues there about responsibility and just what you are talking about. But do you think that there is also areas where active research in academia should be done for making sure that at the end of our engineering work, we have produced something which is responsible for the people and of course from the environment?
So I think there's plenty of research to be done, like across all of the engineering disciplines, whether it's developing new technologies or materials or sensors or new science methods to better understand, the processes and the assets, but also across the social sciences, so we can have a better understanding of the real true life cycle cost of any of these different solutions that we put forward, not just the single bottom line accounting that drives so much of the economic models that we rely on. Research in terms of trying to better understand the uncertainty with which we address non-monetary value to whether it's our environment or people's safety, and that varies greatly around the world. The value on a person's life that is placed in the UK compared to in some of the places where a lot of our goods end up being dismantled and disposed of. And then I think there's research in the economic models that could underpin this, that would enable that innovation to really embed design for decommissioning at the outset, which often doesn't get to fly with the single bottom line accounting of what is cheapest now. And of course, research into the regulatory frameworks that will underpin any of those decisions and solutions.
Absolutely, and I think that international dimension that you just mentioned is extremely relevant, because of course, I mean, there are ethical issues there, and this has really very much flagged to me something that I would like probably to touch upon in my lectures on ethics in engineering, because as you said, some of these products can end their life in places where they have not been produced, and we can harm people in different countries, and we have to be aware of the impact of what we are doing, not just around ourselves, but in the international arena. Now, also, I think you are doing so many things, Susan, and I should declare that, you know, I know Susan because we have been interact through the chairs in emerging technology. So you are doing such an excellent work in your area, outside your area actually, and I know that you have the chair in emerging technology, of course, but you are also joining us today as part of the Engineering Act Safer End of Engineer Life program. This is a program from the Royal Academy of Engineering. Can you please tell us and the audience a little bit about the background of this program, and also what is the involvement, your involvement so far?
Okay, absolutely. So as you say, yes, I'm part of the program board for the Safer End of Engineered Life, and this is part of a broader program called Engineering X, which is an international collaboration that was founded by the Academy with Lloyd's Register Foundation, with a mission to reduce accidents and incidents and casualties, as you mentioned, in dealing with products and assets at the end of engineered life. And really, one of the core messages from the program is that we should be trying to embed how to deal with these products at the end of engineered life, you know, at the start of the design process, not just to design what seems to be on the metrics we have, the most efficient and effective solution, only to get to the end of engineered life and then simply export it somewhere else to be dealt with by other people. And so I became involved in the programme through the first part of the programme, which was safer decommissioning of offshore structures and ships. But the Safer End of Engineered, I should say first actually, that the Safer End of Engineered Life programme is really just one of several projects within the Engineering X. There is also programmes on engineering skills where they're most needed, on safer complex systems, and in response to the pandemic over the last year, on pandemic preparedness. So there is an enormous breadth of work being carried out. And then within the Safer End of Engineered Life programme, the first aspect that we addressed there was safer decommissioning of offshore structures and ships. And that was, you know, partly because of the insights that the funding partners, Lloyd's Register Foundation, have in terms of recognising that that was a significant challenge that needed to be addressed for shipbreaking, and also for the existing legacy items from the oil and gas industry, and then looking forward to all the renewable infrastructure that is coming online now. I mean, remarkably, the same amount of infrastructure has been installed in our oceans in the last decade as were installed in the 50 years before that. So there are huge asset bases that need to be dealt with. And so I got involved because there was an open call for a convener for a global workshop on safe decommissioning of offshore structures and ships. And so it was just advertised on the Academy website. So I applied, and there was a selection process, and I was chosen to convene this global workshop. So then I got to work with this amazing team at the Academy, and we created a programme for a 2-day workshop and invited, you know, all manner of people from across the globe and from across both of these sectors, which in some ways are quite similar, but in other ways quite diverse. And we had this 2-day workshop in London in the summer of 2019. We had more than 60 people come from 20 countries, and we really had people from all across the sectors. There were owners of from shipping companies and from, you know, oil and gas companies. There were engineers and technologists and lawyers and people working all across the industry in that sense. There were people who owned shipyards, and there were NGOs and charities representing the workers at those shipyards. So it was a most amazing mixture of people, and that really came out of the workshop that everyone said they had never been at an event where there had been such a diversity across the sector. And so I think that is something that is also very much in keeping with the Engineering X programme. It's about giving a voice to those who don't often have a voice, and really trying to bring the whole diversity of people involved together. So I had this wonderful workshop in London for 2 days, and then as a result of that, there was a call for funding applications through consortia that were created at that workshop, but with an opportunity for people to bring in other partners who hadn't been involved that might be valuable to the project. And as a result of that, we funded 6 projects, which are currently ongoing. So these are 6 projects, and each of the projects is a consortium. Sometimes there are maybe 12 partners, and in other cases, maybe 2 or 3. And the projects, they range from really on the ground, like activities and interventions and assessments of shipbreaking yards and decommissioning facilities in those areas where the risks are most prevalent, through work in terms of raising awareness and representation of the workers in such places, and dealing with interactions with those who own the assets that are going to those places, and also gathering data and creating an evidence base about end-of-engineered life of offshore structures and ships. So there really is a thorough and comprehensive data base on which we can plan future research and policy activities and so on. And so all those projects are currently ongoing. Some of them are a years-long project, and some of them are 5 years projects. So they will actually outrun the scheme itself, as it were. So a huge diversity of activity going on there. And then as a result of this decommissioning of offshore structures and ships programme, I got invited to join the programme board, which oversees other aspects of the Safer End of Engineered Life programme. And so another part of key aspect of Safer End of Engineered Life was the commissioning, and actually the recent publication of a global review on Safer End of Engineered Life. So that has just been published and is available on the Academy website. And this is a really comprehensive assessment of what happens to all manner of engineered goods at the end of life. And this is medical waste and e-waste and construction waste and domestic waste and a whole range of things. And what really was highlighted by the report, which was carried out by researchers from the University of Leeds, Dr. Kostas Velis and Dr. Ed Cook, they really identified that actually the vast majority of goods and products end up being burnt or dumped in these unregulated sites, in particular areas in the global south. And so this had been an area that hadn't had a great amount of publicity or profile recently. So the Academy then ran with this and tried to raise awareness of uncontrolled burning and dumping of waste. So as a result of that, there were a couple of global workshops. They happened just this month, actually, and they were convened by Dr. Mansour Ali and Dr. Terry Tudor from Learning in Development. And just like when I became the convener of a workshop, that workshop convener and with Kostas and Ed as well, writing the report, is all just an open call for people to put themselves forward and to get involved. So yes, so Mansour and Terry, they organised these workshops with the team at the Academy. And so that was really bringing together a huge range of people, 150 participants from 40 plus countries, again, from all aspects of the waste sector, to really validate some of the findings from that global review and to share suggestions and thoughts about how to improve the situation. So that is really what's been happening with the Safer End of Engineered Life programme.
Oh, quite a lot, yes. And of course, I mean, you started before the pandemic, and I see that you have continued through the pandemic. I hope the pandemic has not been a deterrent to continue the work. I hope that you have been able to continue the work also under this very peculiar situation. Is there any way that our research fellows can get involved? What do you see for the future? And if someone wants to get involved, how can they get involved?
Okay, so well, you can get involved just by getting in touch with the team at the Academy. So you can find their information, details on the Royal Academy of Engineering website. Hazel Ingham, the very wonderful Hazel Ingham, is the Programme Manager for Safer End of Engineered Life, so you can contact her. There is a community of practice that came out of the burning of waste work and workshops, and so they have a LinkedIn group. You can just search for that and join this community of practice and find out more about specifically those events there. But also in terms of like a next activity for Safer End of Engineered Life, there is going to be an open call that will be announced later in the year, probably in March, seeking champions for other areas of Safer End of Engineered Life. So this is an opportunity for individuals to put themselves forward and approach the Academy, but not specifically in response to a call like I responded to a call about decommissioning of offshore structures and ships, and Costas and Ed responded about something specific in terms of creating this review, and equally Mansour and Terry, they responded to something specific. This is much more open, and we chose to be not prescriptive about the sectors that we wanted to have a look at or the particular challenges, in order to really throw it open to anybody who was working at the end of engineered life to raise where they see as being critical issues. So it's really very open, but just to try and narrow it down, if people are thinking, oh, well, I don't know if that's me, like some areas might be medical and PPE waste, which of course is an increasing problem in the last year and a bit. E-waste, perhaps renewable energy waste. A lot of renewable energy, well, certainly wind turbine blades are constructed from composites, which are certainly not as easy to recycle as steel platforms, for example. Composites used in a whole range of other things as well, and how best to deal with safer end of engineered life for any of those aspects. Or perhaps something more methodological and philosophical, if it was about designing for decommissioning, design for demanufacture, if as a sort of umbrella, this is something that you have experience and a vision about, then you would be just the right sort of people to put yourself forward and approach the Academy, and then that will lead on to some conversations about how we could support you to make a difference. So that is due to come out sometime in March. It will be advertised on all of the Academy's media channels, so on their website and on Twitter and LinkedIn and so on. So just keep an eye on that, or contact Hazel and she can add you to the mailing lists and so on.
Yeah, thank you. And I can see that in the chat box, there is just the email address of Hazel for the ones who wants to get in touch. And kindly Sharad has also put a link to the report that you are mentioning. So I think that everybody who is interested, I will definitely go immediately after this and look at the report. Now I think that I would like just to open a little bit to the questions from the floor, and please don't be shy. Just put your question into the box, and if you like to ask the question in person, please raise your hand. I will try to go from one box to the other one, I think. Let me start. There is a question. I don't know if it's really a question or rather a statement. Yeah, I think that from Ruth Brumfey, and the focus for all Engineering Acts programs is international collaboration and working across international borders on problems that affect the society. Yes, this is absolutely, I don't think this is a question, this is just a statement. But definitely we have seen that, but I don't see any other questions. But I think from me, one thing that I wanted really to ask you, I'm a little bit curious, and of course, I mean, we all try our best, but what would be your suggestion, your hint to an engineer like me or anyone else to keep in mind? How should I, this very important issue, how should I start my work? What is, give me a hint, give me a little suggestion. What should I have in mind when I start my work to make sure that my products or from my work are going to be safe. Well, safety, I think it's included in what we do nevertheless, but more importantly, that I take into consideration their end of engineered life.
So I think it is tricky, you know, because we're all set, you know, particular challenges to meet, and sometimes, you know, it's easy to get trapped within those boundary conditions and not really think beyond that. But I think it is quite simple, and it is about trying to imagine what is going to happen at the end of engineered life for whatever the product is. Is it going to be, you know, easily recyclable or reused or disposed of? What are the hazardous materials being used in it, and can they be extracted from the product and dealt with safely? Will that be dealt with by the manufacturer of the good, or is it something that is going to be outsourced? So I think aspects of like modular design, obviously, you know, assist with this. If you can have some plug and play bits where, you know, some bits are easily recyclable, hazardous parts are easily removable and dealt with in a specialist way. Can the work be focused towards finding non-hazardous replacements for some of those, you know, chemical processes or activities that need to go on? So I think just being mindful about that, but equally, you know, I think we are more mindful as a research community at the moment. We have to think about responsible research and innovation, you know, all of the time now, and how could our research be used, you know, for not the intentions that we had. So I think it's just broadening out that, think about how our research is going to be used by society, and when it's not being used by society anymore, what's going to happen to it. And I think we mustn't always think that it's going to be an engineering solution, for sure. We need to be constantly challenging that. If it's always single bottom line accounting about how to do things cheaper, that is not going to enable that innovation really to develop products that might be in the whole life cycle of ways better for safety of people, safety of the environment, and more responsible and sustainable. Is unlikely to be the sort of the cheapest option at the outset. So challenging what those models are, how we value the health of people, the health of the environment, and bringing that into the economic models that you know, then leads to the cost of products, I think is critical as well.
Yeah, I think that, you know, there has been a little bit, and I have observed this also, like I said, in teaching ethics, just to analyze what happened in the past and try to rectify now. I think that probably we should really move towards a more anticipatory way of working. And in other words, instead of basing ourselves on case studies or something which has been very good or very bad in the past, we should start to think probably from the beginning and see how can we divert what we are doing in a better way. Like I said, you know, it's very much when you do case studies in ethics and you study about disasters from the past, but I think that more important, you should be anticipatory in what you do and see how you can avoid that disaster in your design and in your engineering products. And speaking about case studies or examples, there is a question actually from Sharat from the Academy. You have any good examples that you know of either industry or sectors as a whole, or particular companies or products that champion circularity, and so that we can learn from these good examples?
So that is an excellent question as well, and certainly embracing a circular economy and the circularity of goods from design, like through its you know, the manufacturing, the operation of an asset, you know, and then trying to reuse as much as possible of that, so it doesn't become a waste product at the end. And certainly I think there are pockets of good practice that we can learn from, and the challenge, I think, is to make that global, that it's not pockets, and that those the design philosophies that underpin organizations that embrace circularity are accessible, become accessible to the mainstream, and that needs to occur through the economic levers that will be available to us. I think circularity is, like a fantastic template for us to consider, and perhaps related, but, and I think this relates to what you said before, Raffaella. It's not just about doing what we're doing a little bit better. Like, we really have to change the way we're doing things. We have to reinvent and reimagine. And should we consider that, our use of all of this stuff and all of our products and assets, do they always have to be extractive? Are there regenerative philosophies that means that we can, work in harmony with the environment? And so it's not necessarily just about minimizing damage, but could we be, actually like coexist together? And I think there are, thought leaders out there, pushing forward, ideas about how we could, retrain our brains about, prioritizing what is important.
Yeah, there is a question from Muir McDonald. She said, super conversation. Thank you, Muir. Susan, to you this question: in maintaining increasing safety of complex infrastructures, can you talk to the dilemma of balancing the options of extending the safe life, taking out of service early, disposing and replacing with newer solutions? And where do we see good practice here? That's a great question, actually, because yes, I love it, because unfortunately, as engineers, we always have a dilemma, right? So we have to find a balance. Yes. So Susan, to you.
It is a great question. Thank you, Mia. So I think, it is certainly complex systems and complex infrastructure, and a whole range of dilemmas to be balanced. Certainly, if we can extend life of the desired life of something, it puts off to some extent when it's going to have to be disposed of and dealt with at the end of engineered life. But equally, too much life extension, particularly if it's more about stalling because we're not really sure how to do it best or safely or economically at the moment, means that the structures that we end up then having to deal with are perhaps, lacking in structural integrity, or, that they have already started to, break apart in small or large parts and become less safe to deal with. So, of course, definitely a balance there. If products and things are already being dealt with poorly, taking them out of surface early, perhaps not so, will not necessarily help the situation, because they will have to be dealt with eventually, but certainly changing the type of structures and not keep putting in the same structures and products into the economy would help. And I suppose displacing and replacing with newer solutions, yes, and as and when they should naturally take place. So I suppose it's like the diesel to electric car argument. We shouldn't all go out and throw away our diesel cars tomorrow and buy electric cars, but certainly as we are all moving towards changing cars and things, and you need to think about more responsible ways of doing it as an individual, but I think as the sector, you need to be very far ahead of that, thinking about, what are the options that you're providing with society with. So I hope that was a very good question, and quite a big question. So I think that's some thoughts on it.
Yeah, thank you. I see also another questions from people. The issue of plastics in the ocean got a lot of emotional traction with the public because of Sir David Attenborough, of course, through the TV program. Do you have an idea of what data images might capture the public imagination? That's a very good point, because I think that that's another issue that we should deal with and make sure that everybody's on board.
And
even if the data have not yet be gathered. So what is something which can attract the
So I think about embracing everybody. I think the data is important, the imagery is important, but understanding what creates behaviour change as well is going to be increasingly important. There has been too much plastic in the oceans for years and years. People have this emotional response to it, and there is some change, but there are still 8 million tonnes of plastic going in the ocean every year, even though we're all aware of it and we have the data and we have these, very striking imagery of what the consequences are. So, you know, what is it that we need to do in order to actually change those behaviours? And interestingly, like in terms of, you know, offshore infrastructure or something, if you compare the volume or the mass of infrastructure compared to, you know, the 8 million tonnes of unwanted plastic that ends in the ocean every year, you know, these are quite useful benchmarks for how we deal with the rest of our waste. One of the outcomes from the burning of waste workshop was that if waste is not burnt, is it going to unintendedly end up in the ocean as well? So it is a very complex, a wicked problem that, you know, changing something in one place is going to have knock-on effects in the other place. I think there is a lot of very striking imagery about end of engineered life. I mean, flick through the imagery in the global review of a safer end of engineered life. It is appalling, you know, conditions that much of those in the global south are living with piles of rubbish and whether imported or whether because there's no waste disposal provision, you know, in the area in which they are, and they're, you know, forced to burn in order to keep sanitary conditions and so on. But equally, you know, with you know, old power stations and things that are on the landscape, we can see, you know, I'm sure Raffaella knows across Scotland, the North Sea oil rigs that have been brought onto shore to clean up. These are just vast structures that are then, you know, cleaned on shore and then recycled and disposed of on shore. So I think there was a lot of very striking imagery which really shows the magnitude of like the stuff that we are dealing with, but it's had to move past that like sort of shock and awareness to actual action. And I think that is, you know, something that we're all trying to, you know, how best to do. And again, another reason to ensure that all the work that we do is multidisciplinary and really embraces, you know, the social sciences, so we can understand, you know, where the levers are in behavioural response to, you know, stop it either at the start end of things or at the disposal end of things.
Yeah, absolutely. Of course, I mean, there is a very large component which has to do with our behavior. And we have seen this also for the pandemic. I think, you know, our behavior can affect enormously what the outcome of how we are, where we are going and what we are doing. And in fact, there is a question from Hazel that says exactly this. I mean, she says, a very interesting conversation. In most cases, was the safe end of engineered life something that was considered in the design of the sorry, I'm speaking. I'm switching one question. I will go to the social behavior later. Sorry, I'm reading something else. I'm reading from Kevin Briggs. It says in most cases was the safe end of engineered life something that was considered in the design of the assets, or is the main challenge with identifying and mitigating the hazard from existing assets? Yeah, that goes together with the anticipatory, I suppose, things that we were discussing before. And my camera starts again too.
So that is another great question, Kevin. And I think it's both, really. Certainly in my area of ocean engineering, there's a huge legacy asset base from the hydrocarbons industry, of course, with, you know, much hazardous material around oil and gas rigs that needs to be dealt with. But equally, this legacy asset base is going to be a small fraction of what the renewables asset base is going to be like now and looking forward as well. And so that is our opportunity to really embed design for decommissioning at the design stage, rather than just keep doing what we're doing. Because, you know, up to a point, I would say that, you know, even our current renewables development, although an absolute necessity in terms of addressing decarbonisation of our society and economy, you know, we could do that. We could challenge and do that perhaps better as well, looking at the whole life cycle consequences of how we design new renewable power generation infrastructure and so on. So I think it's definitely about both of those things. There is already huge asset bases of PPE that needs and e-waste that needs to be disposed of. But could we look at, you know, e-gadgets in the future, PPE and medical equipment in the future being designed to be more easily disposed of or decommissioned, something that is biodegradable or reusable or recyclable in a more sustainable way.
Yeah, the other consideration I thought, and there was specifically a question from Hazel going back to the behavior, the public behavior. Hazel says, do engineers have a part to play in influencing change in the behavior or in policy? Because of course these two elements are absolutely crucial in what we do. Do you think that we have, well, probably in policy, I mean, but in social behavior, do we have a consumer behavior? Do we have anything that we can contribute in that area?
So absolutely, I think that there's always a bit of a sliding scale, isn't there, of how to influence the public. Some amazing engineering interventions in the past, whether intentional or not, have had fantastic effects on environmental sustainability, like the LED light bulb, or this story about how improvements in washing powder enabled you to get clean clothes at a much lower temperature, and this led to much less energy usage and so on. So I think there's, engineers can clearly influence consumer behavior, and particularly if it makes life easier for the consumers. The LED light bulbs are cheaper, they last longer, people want to use them. And of course they want this lower electricity bill. So if they can buy a powder that will mean that they can wash their clothes at a lower temperature, these are going to be easy. And I think, the difficulties obviously arise where we haven't quite identified how to make it easier for people. There is a lot of the plastic in the ocean doesn't come from, from the developed countries that have, very established waste management programs in them, although there is issues about whether or not some of this plastic is exported or not. But a lot of it is about products that are used by people who don't have a choice about, what else to do. So, how to influence, perhaps not them, but the manufacturers who are relying on their need is perhaps where that behavioural change needs to happen, not necessarily always with the consumer, but with the manufacturer who is relying on that consumer's needs.
Yeah, and of course, I mean, I'm sure that you have seen the latest data. Engineers are the third profession more trusted by the public after nurses and doctors, and I think that's a big achievement. But of course, I mean, to keep the trust, I think that we have to behave well, also for the future generations. But also, probably we can really have a little bit to say and to be go a little bit more public. Probably, do you think, Susan, that we have been as engineers, as professionals, a little bit too quiet? Should we speak a little bit more and be more out there to speak about what we have done, unfortunately, ourselves bad, and what we can do much better?
Well, yeah, I think it's always good. It always surprises me that, there's so much of the population doesn't really know what engineers do. And this is why things like, this is engineering campaign from the Academy is just fantastic, really showcases to the general public and especially to young people, really the diversity of, what engineering is and what engineering does. So I think there's multiple levels at which we all need to get out there and shout about, what it is that we do. But equally, in some aspects of engineering and construction, there's a lot of bad press. So I think it's about like that sort of collaboration, if it is, between like the economics and the business models and the engineering and the press, in terms of shaping the public's view of what we do. If papers and the news are all full of things being over budget and over time and going through areas of outstanding natural beauty or damaging our environment, or this is not a good angle, even if it gets more readers for the newspaper. So I think there's many levels on which we can engage better with the public about the value of what we do as engineers. And it's very good. I hadn't heard this data that we were the third most trusted profession, but that is wonderful. And that is a responsibility as well. We must continue to earn that trust, maintain it.
I think we have time for a last question. Anna Hong, continuing on from what Hazel said, do you think engineers can influence large organizations to build products that last longer with proper disposal in mind? It has been known for decades that organizations build their products in a way so that they eventually break, forcing the consumer to buy another upgrade product. Yeah, that's, of course, yes, that's, and you know, yeah, Susan, I think, I don't know if it's me, but Susan seems to be frozen. You're back. Susan, I don't know if you heard my questions about from Anna Hong.
I did.
Yeah. So sorry, you are frozen for a second. I don't know. So okay.
Frozen, but I was still taking it in, so that was
that's good.
And I think, yeah, a great question. I think it's definitely not something engineers could do by themselves, but often just saying what the problem is never going to solve anything. So you need to put the solution forward. Often, you know, this business will say no to the solution, but at least if there is a solution there that can be proposed by the engineers, then there is something to, you know, build a momentum to persuade, you know, policymakers and businesses to adopt these practices. And there is such an important role in terms of like the economic models. If big organizations were, you know, costed or taxed on the amount of rubbish that was caused by their products, so if everything was only designed to last a year and they were taxed on, you know, that volume of stuff that was then going to become obsolete after a year, perhaps, you know, that would be their nudge to make things that lasted for longer. So I think it's a very complex and, you know, interdisciplinary problem for sure. Engineers have got a critical role to play in that, in terms of providing the solutions that things will last for longer and can be disposed properly. But that whole ecosystem about how to make that, you know, work in a business network is really, really critical as well.
And perhaps also things that can be fixed. Because, you know, I always used to say that, you know, I became an engineer because I used to look at my dad fixing things around the house, fixing my shoes, making me so happy. And I said, yes, I want to fix things. I want to be an engineer. So, I mean, sometimes even fixing, and, you know, we dispose things, and, you know, they want to replace my mobile phone every other year just because make more money. And I think that it's, yeah, it's a social behavior as well. And I think that probably we as engineers should influence also in that arena. I don't see any other question. It's your last chance if you have any question, urgent question to ask. If not, I really think that I would like to thank everybody for being here, but specifically and mostly Susan for this very intriguing, excellent, and inspiring, I would say, conversation. It opens always our eyes when we see things that we can do differently and much better than we do sometimes. And we will be holding another Academy Cafe soon. And we hope that some of you will be able to join us in this series. If you have any topic that you would like to see covered, please let us know. Again, you have seen as emails, but there will be an email or also when you will get the feedback from the Academy. There will be a feedback form that will be circulated following the event. So once again, I really would like to thank everybody thank Susan, the Academy, of course, for organizing all this and for the opportunity. And I don't like to thank my webcam, which is really not behaving very well today. So thank you very much. Stay safe and see you soon. Goodbye.